My name is Adrian, and I'm a senior audio programmer at RevRooms and the author of our new ambient system. The ambient system is made to play ambiental sounds for huge environments and the thousands of objects that make up forests, cities, and open worlds. It removes the need to hand place audio emitters. Its main purpose is to drastically speed up a designer's workflow by having some simple setup steps regardless of the size of the map. Our designers have already showcased how the system works with huge environments in other videos, and I'm here to quickly explain to you the technical aspect of it, which is simple but can easily become as complex as you need it to be. For this purpose, I have a simple map with some cubes and a plane. The cubes are part of two biomes, the blue biome for the blue cubes and the red biome for the red cubes. These can be hundreds or thousands in number. The system is built so that it adapts to that. The ambient system works with Wise's spatial audio volumes, which are a built-in feature of Wise, which works off the bat with spatial audio features. The room tone in our case is a complex ambience bed, which plays all the sounds that our ambience area will play. Of course, all these sounds, they don't need to play at the same time. They are driven by a number of RTPCs defined in our ambience area component. The ambience area component is split into layers. In our case, we have split it into two layers, the blue biome and the red biome. You can have as many layers as you want, just as you can have as many spatial audio volumes with this component as you want in your map. Each layer works with gameplay tags by figuring out which assets belong to that layer. In our blue biome, we want assets that are tagged with the blue biome tag. The blue cubes also have this tag attached to them. So in any blue cube, you will find an ambience asset user data with the ambience tag that we wish to scan for. We can have as many as we want. So for example, the cubes with a blue sphere, they also have a birds tag, which we will go into a bit later. This is one way to tag these assets by going to the actor instance and attaching an asset user data. But if I have hundreds of copies of the same static mesh, for example, a tree with different rotations and scales, I don't want to tag each individual one. Instead, I can go to the content folder and tag only the static mesh in the U asset. And all the copies of it in any map that are referencing the static mesh will automatically get that tag as well. So it's a very efficient way of tagging assets without having to manually tag each one of them. Going back to our bed layers, each bed layer has a number of RTPCs. The first one is the density RTPC, which gives us a normalized value between 0 and 100 about the area that is covered by our assets within the ambience bed's attenuation radius. So if we're fully surrounded by forest, this value could go up to 100. If only half of the attenuation radius is filled by the forest, then this can be somewhere around 50. The asset count RTPC is a non-normalized value of this, so it tells us, hey, there are exactly 160 trees around you with a 50% coverage area, for example. And the last RTPC is the minimum distance, which gives us the distance to the closest asset for this particular layer. Having this set up and surrounding the map with our spatial audio volume, we can now hit build, and the system will offload its most expensive calculations at edit time, splitting the volume into a grid. The cell size can be manually adjusted depending on your granularity. And we can see here that for each cell that is overlapping with our assets, it has marked it with a red cross, meaning that it has found assets in this part of the grid. So if we click away and if we'll click back, we can see that the blue cubes have been detected. The green dots represent the density values. So of this particular biome. And in the ambience area, we can select to visualize only a particular layer. So for example, the blue layer, we can see its density value. And for the red layer, in a similar fashion, we can see its density value as well and the assets that it has detected. The visualization in the editor simulates the player's position under the mouse. The big white circle is the ambience event's attenuation radius, and as we simulate the player moving through this area, in the top left side of the screen, we can see the RTPC values going up and down, giving us a good idea of how the system behaves at runtime with a bird's eye view over the map. At runtime as well, we can visualize the same values as the player moves around the map with extra information about the events that's playing and the volume that the player is in. That is the ambient system in a nutshell. An important extra feature of the ambient system is its ability to play localized spot events. For example, we have a forest which has a couple of magical trees, and these magical trees have in them magical birds. And on top of the ambience um, event of the forest, we want to play these magical bird events, where these magical trees are. So in our case, we have marked some cubes with a white sphere, making them special. And for these cubes, we have added an extra tag with the birds, um, the birds tag on top of the biome tag. In our ambience area, in the spots section, we can define these spots events, one for bluebirds and one for redbirds, in a similar fashion that we defined the biomes. Only that now we have a start event and a stop event, a maximum number of voices, a minimum distance between the spots, and the height from the ground. So this system, with a maximum number of 4 voices, will detect assets that are meant to play the Bluebirds event, and it will randomly pick up to 4 of them and play the event in those locations. And in this way, we cover a lot of ground by playing a complex ambient event that it's meant to give off the ambience of an area. And on top of this, we can tag certain assets with certain type of properties, like the magical birds for the magical trees, which can play localized events. I hope you enjoyed this video, and I highly recommend that you also watch our designers' videos showcasing real development scenarios with landscapes and thousands of assets, and also the way they have set up the complex bed events in Wise. I'm looking forward to seeing how this system grows with your feedback, and I hope that you will enjoy automatically placing thousands of emitters and creating complex ambient events in Wise with literally the click of a button. I will see you soon, and thank you for watching.